Hi there, everyone. My name is Dheeraj Bandaru. I am a product manager for Azure Static Web Apps. And today I'm super excited to be here to talk to everyone about deploying web apps to the cloud for beginners using Azure Static Web Apps. So if you're a dev looking to create powerful modern web applications with ease, you're in the right place. Today we're going to explore what Azure Static Web Apps are and why they might just be the perfect solution for your next project. Let's get started. So Azure Static Web Apps, or SWA for short, is a service provided by Microsoft Azure that allows you to build, deploy, and host static websites and web applications in the cloud. But what does static mean in this context? Well, in simple terms, a static web app is composed of fixed content, such as HTML, CSS, and JavaScript files, which don't require server-side processing when a user requests to view them. Static web apps could be used for sites that don't need to frequently update content dynamically, such as personal blogs, portfolio sites, or even certain types of business and marketing websites. The benefits? They are incredibly fast to load, cost-effective, and inherently more secure as there are no server-side components that malicious users can target. One of the standout features of Azure Static Web Apps is its tight integration with popular frameworks and static site generators like Angular, React, Vue.js, and Hugo, amongst others. This makes it easy for developers to get started with the tools they're already familiar with. But that's not all. Static web apps can also support your dynamic websites. A dynamic web app content can change based on user interactions, time, location, and other factors. It involves server-side processing to generate the web page sent to the user's browser. Examples of dynamic web apps include e-commerce sites, social media platforms, and online banking. So let's go through some of the key features of Azure Static Web Apps. Azure Static Web Apps has a global content delivery network integration. This ensures low latency and high performance by distributing your content across multiple geographically distributed servers. It also has full CI/CD workflow with GitHub Actions and/or Azure DevOps. Built-in authentication and authorization is also available, along with custom domains and free SSL certificates. Finally, to support these dynamic web apps, Static Web Apps provides managed backends and linked backends. Azure Static Web Apps offers different hosting plans to suit your needs and budget as well. You can choose from 3 different plans, including free, standard, and dedicated. With all that in mind, let's go over some of the deployment methods that will help us get started on Static Web Apps. Currently, we offer 4 methods to get to our service. GitHub Actions and Azure DevOps, as previously mentioned, are automated workflows for continuous integration and deployment. SWA CLI is a command line tool for managing static web apps that can be used to deploy. And VS Code has an integrated development environment with deployment capabilities. With all that in mind, let's get started with our deployment journey. All right, welcome everyone to the second chapter of deploying your web app to the cloud for beginners. We're going to begin our journey today by going over some key terms and concepts. The first one that I want to talk about is CI/CD pipeline. This was mentioned earlier. It stands for Continuous Integration and Continuous Deployment Pipeline. Essentially, this allows users and devs to make changes in one place and have it automatically deployed to the end state. In this case, it would be Azure Static Web Apps and Azure. Today, I'm going to use GitHub Actions to deploy my app. GitHub Actions is a powerful feature of GitHub which allows you to build this automated workflow for your repositories, so that building, testing, and deploying your code is as easy as pushing to the GitHub repository. Azure Static Web Apps has a really great integration with GitHub Actions, making it easy to deploy your app to the cloud in minutes. So before we begin, there are some prerequisites that we will need. 1, a GitHub account. 2, we need to have a GitHub repository to host our static web app, the code for our static web app. And 3, an Azure account and for an Azure subscription within that account. I am now going to show you how to deploy your Next.js website to Azure Static Web Apps. At other parts of this video, I'll be adding functionality to a React app, but the steps should remain the same for your Next.js app. Let's get started. I'm going to go into my terminal here, and I'm going to run a couple commands to initialize my Hello World Next.js app. Here we're creating a sample app called swa-next.demo. I'm asked a couple questions. I'm going to go ahead and click yes to that. All right, now that our app has been created, let's go check it out and move into that repository. I'm going to see what files have been created, and I'm going to go ahead and run this locally. All right, let's go ahead to localhost 3000 to see what our app looks like. And there is our starter Next.js app. Now that that's created, let's go ahead and push this to GitHub so that we can get it into the cloud. In order to do this, I've already created a GitHub repository, and now I'm going to initialize it here. I'm going to add all of the code that was generated. I'm going to commit it as the first commit. I'm going to change to the main branch. All right, now that our code has been pushed up, let's go ahead and check it out in our repository and see if it has made it to GitHub. I'm going to go ahead and refresh my repository, and our code is here. Now I'm going to go to the Microsoft portal. I'm going to go ahead and find Static Web Apps. I'm going to create a brand new static web app. I'm going to name it swa-next-demo. We can see that a new resource group is created on behalf of us for creating this web app, static web app. And I'm going to leave all of these as is, and our source for deployment is GitHub. I'm going to go ahead and find our repository, which is swa-next-demo, the main branch where our code is. We can see here that Next.js has been detected and the application is at the root. Let's go ahead and review and create this. All of these look good to me, so I'm going to go ahead and click create. At this point, we are getting our static web app provisioned, and once this is successful, we get to go to the resource. Our code is not in the cloud just yet. In order to see that process, we're going to have to go to deployment history and the GitHub action runs. I open that up in a new tab, and here we can see that Azure Static Web Apps has set up a CI/CD pipeline, as we discussed earlier. This pipeline allows us to push changes to the GitHub repository, to the main branch, and see those updates reflected in our live site. Currently, this GitHub Actions workflow file is running to deploy our code to the Azure Static Web App that has just been created. We can see what that process looks like by clicking into that, and then clicking on Build and Deploy Job. After seeing all of these logs and waiting for a little bit, we can now see that our site has been successfully built and deployed. And if we scroll all the way down, we can get a link to our final site. I can go ahead and open that in a new tab here. And our Next.js sample app is now out on the web. Just a quick note, if you are receiving an error that says you are using Node.js 16.20.2 for Next.js Node.js version greater than or equal to v1817.0 is required, you will have to go to your package.json file and add the following lines: engines, and then have Node greater than or equal to 18. Thank you so much for following along. And in the next couple of videos, we're going to continue to add some functionality to your deployment to static web apps. Hello and welcome to Chapter 3 of our beginner series of deploying web apps to the cloud using Azure Static Web Apps. In today's episode, we will be discussing custom domains and how to set them up. Let's jump right in. I'm going to begin by asking the question, why do we even need a custom domain? Custom domains are critical for branding and establishing trust with your users. Instead of having a website URL like yourapp.azurestaticapps.net, you can personalize it to yourdomain.com. But how does this actually work? This magic happens with the domain name system, or DNS. Think of it as the phone book of the internet. When you enter a URL in your web browser, DNS translates that human-friendly domain name into the IP address of the server where your content is hosted. There are two types of DNS records that we should be aware of today. The first one being an A record. An A record is a DNS record that maps a domain name to an IP address. For example, if you want to point yourdomain.com to the IP address 123.456.789, you would create an A record for yourdomain.com. A CNAME record is a DNS record that maps a domain name to another domain name. For example, if you want to point your www.yourdomain.com to yourdomain.com, you would create a CNAME record for www.yourdomain.com with the value yourdomain.com. A CNAME record allows you to use the same IP address for multiple subdomains without having to update each one individually. So let's get right into how we can do this for the website that we deployed in the previous chapter. The first step would be to buy a domain with a domain registrar. So today I have bought a domain, swademo.com, on DreamHost. In the configuration of this domain name and purchasing it, it asks me if I want to use the DreamHost name servers or use another host's name servers. Today I'm going to use another host's name servers. Namely, we're going to use Azure's name servers. I'm given 4 name servers here to fill out. Where do I get these from? So I'm going to go to my Azure portal, and I'm going to go find DNS zones. We are going to have to set up a DNS zone for this domain that we just bought in order to fill out those 4 fields. I'm going to go ahead and click Create. Create a new resource group. And I'm going to set the name to swademo.com, as that was the domain that I had purchased. I'm going to review and create that. Everything looks good to me. And we're going to go ahead and set up that DNS zone. Here you can see I have 4 name servers provided to me. I'm going to take these and put them in my DreamHost, where it requested that I give it 4 name servers to set up my DNS zone for the domain that I just bought from DreamHost. Now we're going to go back to the Azure homepage. I'm going to go ahead and find the static web app that I created in the previous section. We can go ahead and check the URL again just to make sure that it's the same website that we had just deployed. Boom. There it is. And now we're going to go to Settings. Under Settings, we are going to see the option to set up custom domains. We can see here the domain that was given to us initially is present and validated. It's an auto-generated URL. But in the top left, we have the option to add more custom domains. As we've just created our DNS zone using Azure DNS, we're going to select that option. we can see here swademo.com is present as a DNS zone. I'm going to go ahead and click Add. Now that our custom domain has been added to our Azure Static Web App, we can see here that the status says validated, type custom domain, and swademo.com is now associated with our SWA React video deployment. If we go back to overview, we can see that the domain name has now changed to what we had asked it to be. I'm going to go ahead and open this in a new tab. And we continue to go back to that same deployment we had before. But this time, it's to swademo.com. And that was adding a custom domain to your static web app. In the next section, we'll be adding an API backend to our deployment. Hello and welcome to Chapter 4 of our beginner series of deploying a web app to the cloud for beginners using Azure Static Web Apps. Today we're diving into API backends. APIs are crucial for extending functionality of your web application. And in this episode, we'll explore various use cases and compute options to create a robust backend, as well as going through setting up one of those backends. API backends allow you to build dynamic, data-driven applications and can handle various tasks like data processing, interacting with databases, and integrating with other third-party services. Azure provides several compute options for creating these backends with Azure Static Web Apps as your front end. These compute options include Azure Functions, Azure Container Apps, and Azure App Service. Let's go through the various use cases and compute options available for your Azure Static Web App deployment. Use cases for API backends can vary greatly, but here are a few common scenarios. CRUD operations. This includes handling create, read, update, and delete operations from a database for an application. Data processing, manipulating and transforming data before serving it to front-end applications. Third-party integrations, connecting with external APIs or services for additional functionality would require some sort of back-end functionality. Additionally, authentication and authorization, such as managing user identities and access control, is also something that can be done with an API backend. Now, let's briefly highlight the different compute options that are available for your Azure Static Web App as a linked backend. First, we have Azure Functions, which is a serverless compute service that scales automatically and supports event-driven scenarios. Second, we have Azure Container Apps, great for running containerized applications as well as microservices. Finally, we have Azure App Service, a fully managed platform for building, deploying, and scaling web apps. For today's example, we'll be using Azure Functions. Let's get started. In previous videos, we looked at deploying and setting up some functionality for our front end. But you can see here, we've now added an API. This API is, today, we're going to deploy to Azure Functions. In order to do this, I'm going to have to download the Azure extension in VS Code. I've already have it installed on my local machine. So all I have to do is go to API, right-click, and scroll down to Deploy to Function App. I'm going to go ahead and click that. I'm going to pick my subscription. And I'm going to create a new function app. We can name this anything we want to. Today I'm going to name it SWA Video. We're going to select our version, and we're going to select a region where these will be deployed. Now, we can watch this API get deployed to a function app through this Azure extension output. We can also see it in our portal once it gets deployed. Awesome. So now we can see that the function app has been successfully created. I'm going to go ahead and click Yes to initialize this for VS Code. And now I'm going to minimize this screen and go to my portal. We can see in our current deployment, when we go to the My List tab, it says loading data and nothing gets loaded here. This is because My List requires backend functionality, So going home, we're going to go to Function app right here. We're going to go ahead and find our subscription. And now we're going to see that our Function app is in the portal, as we previously created it, SWA video. And it is actively enabled. Now that we've confirmed that this is available, we're going to go back home to our static web app. And we're going to go down to Settings and scroll all the way down to APIs. Under APIs now, with production, we have the option to link a backend resource. I'm going to go ahead and click that. I'm going to go ahead and select my subscription. I'm going to find my resource that we just created, SWA video. I'm going to set my backend slot as default, and I'm going to link it. Now, what this is doing is linking that front-end deployment we just made in previous chapters to the Function app that we just deployed that has all of our API functionality. Now, I'm going to go ahead and close this. If we go back to Overview, we can go ahead to our domain and see if my list is now enabled. You can see there that now we see data here. According to my list, I have strawberries, sliced bread, and apples. All thanks to us linking our backend API using Azure Function. In the next chapter, we're going to go over security for our web app and what Static Web Apps offers in terms of built-in authentication. Hello and welcome to Chapter 5 of our beginner series of deploying websites to the cloud using Azure Static Web Apps. Today we'll focus on essential aspect of web applications, security. We'll cover authentication options, setting up sign-in mechanisms, custom auth options, and other private networking options available to you in Azure Static Web Apps. Let's get started. Security is critical for protecting your data and ensuring user trust. In the context of Azure Static Web Apps, you'll find several built-in security features and customizable options to enhance your security for your web app. Let's start with an overview of the authentication options provided by Azure Static Web Apps out of the box. Azure simplifies authentication through its built-in support of popular identity providers like Azure Active Directory and GitHub. These providers help ensure that your users can sign in securely using their existing accounts. Now let's see how to set up basic sign-in options. Now we're going to head over to our code and see how this all looks. I'm going to head to my front end. I'm going to head to my public folder and find my staticwebapp.config.json file. I have this file open now, and you can see here, under route API/products, I have allowed roles as authenticated. This means when a user arrives at our website, they cannot view the products page unless they are authenticated. Let's go ahead and see how that looks on our live site. I'm going to head over to swademo.com. Currently, I'm on the products page, which was under my list. I'm not authenticated, and I have the following request failure. I'm going to go ahead and authenticate myself using GitHub. I'm going to click Continue. And now I can see the list of options that I had in my list. Both Azure Active Directory and GitHub are available as built-in options. And to set them up, all we have to do is go to our staticwebapp.config.json file and create allowed roles. Next, let's dive into custom auth. This gives you full control over the sign-in process and can be tailored to meet specific needs, like integrating with on-premises authentication systems or other identity providers not natively supported. Custom authentication is useful when you want to leverage your existing identity infrastructure or provide a seamless sign-in experience for your users. For example, you might want to use custom authentication to configure custom providers using OpenID Connect, or if you want to customize the user interface or the logic of the sign-in process. Finally, let's talk about setting up private networking. Private networking enables you to secure your web app by restricting traffic to specific virtual networks. Establishing private endpoints ensures that your web app is accessible only through your specified virtual network, enhancing security by limiting exposure to the public internet. Additionally, Azure Static Web Apps has introduced the Dedicated plan. This plan offers more advanced security and performance features designed for enterprise-grade applications. Security is a critical aspect of any application, and Azure Static Web Apps provides a host of features to ensure your web app is both secure and reliable. From authentication options and custom auth to private endpoints and dedicated plans, you have all the tools you need to protect your application. In our next chapter, we'll get into preview environments. Hello and welcome to Chapter 6 of our beginner series of deploying web apps to the cloud with Azure Static Web Apps. Today we'll focus on preview environments, an incredibly useful feature that allows you to test changes before they go live. We'll explore the overview and use cases, followed by a step-by-step demo. Let's get started. So what are preview environments for? Preview environments provide isolated testing environments for your application, allowing you to see how changes will behave before deploying them to production. This is particularly useful for features that are works in progress, pull requests, or any updates that you want to validate rigorously. So here are some key use cases for preview environments. One, we have feature testing. Allows you to test new features in isolation before rolling them out to all users. Bug fix verification. Ensure that bug fixes do not introduce new issues. Team collaboration. Allow different team members to review and test changes. Client demos. Showcase new features to stakeholders without affecting the live site. Now let's dive right into the demo to set up and utilize preview environments with Azure Static Web Apps. Here's how you can create a preview environment using GitHub Actions. As in previous chapters, ensure your code is hosted in a GitHub repository and linked to your Azure Static Web App. Whenever a pull request is created, Azure Static Web Apps will automatically generate a preview environment for that branch. We'll start by creating a pull request to demonstrate. Let's go ahead and switch over to our code and let's create a pull request. So in order to do this first, I'm going to create a new branch in my repository. I'm going to see what branches I currently have. I only have main. So I'm going to do git checkout -me. I have now switched to a new branch. All right, now that we have created our new branch, we're going to go change the code and update the home page a little bit. We can see here right now we have manage your shopping list, we have some text. That's all great, but I want to add an image. So in my file structure here, I've added an example image. So I'm going to go ahead and import that into my home page, so that we have it here, like that. And then I'm going to add it into our home screen, like that. I'm going to go ahead and save that. I'm going to go to my terminal. I'm going to zoom in. I see that there are some changes made on the front end. I'm going to go ahead and add those. I'm going to commit and push this to our new branch. All right, now that all of our new changes have been pushed to GitHub, let's go to our GitHub repository in the browser. We can see here that we have a new branch called test feature. In order to create that preview environment that we were speaking of, we're going to go to pull requests, and we're going to open up a new pull request. we are going to select Test Feature. We're going to create a pull request, and we're going to go ahead and click Create Pull Request again. You can see now that a GitHub Actions workflow is running, similar to how it was when we first deployed our app. We can go ahead and click Details to see what exactly is going on. Awesome. Now that our workflow has finished successfully, we can go to the Azure portal. Now that we're in the Azure portal, we're going to go to our Static Web App resource. Go ahead and open that up. And we're going to go down to Settings and Environments. Under Environments now, initially we only saw Production, but now we also see Test Feature, which was the name of the branch we had just created a pull request for. We can see that the status is ready, and we can browse it. So I'm going to go ahead and open this in a new tab. And just like that, we have an image on our home screen. Just to show everyone what our app looked like before, I can go ahead and browse our production app, opening that in a new tab. We can see that there was no image. But now we can see that an image has shown up in our preview environment. And if this looks good, we can merge this change into our main branch and put it into our production app. In the next chapter, we'll go over traffic management in Azure Static Web Apps. Hello and welcome to Chapter 7 of our beginner series of deploying a web app to the cloud with Azure Static Web Apps. In this chapter, we'll discuss the various methods available for managing traffic to your web application. We'll cover overview and testing use cases, traffic splitting, and finally, we'll conclude by introducing Enterprise-Grade Edge, a special feature in Azure Static Web Apps. Let's get started. Traffic management is essential for optimizing performance, enhancing user experience, and achieving organizational goals. Proper traffic management can ensure that your users receive the best experience possible, regardless of their location or the server load. Let's discuss a couple use cases where traffic management becomes crucial. Geographical load balancing. Direct users to the nearest server for faster load times. A/B testing. Run experiments by splitting traffic between different versions of your app. Gradual rollouts. Gradually release new features to minimize risk. High availability. Ensure uptime by redirecting traffic during outages. Azure Static Web Apps makes it easy to implement these traffic management strategies. Now let's delve into traffic splitting, a fundamental aspect of traffic management. Traffic splitting allows you to distribute incoming traffic between different versions of your application. This is particularly useful for A/B testing and gradual rollouts. Here's how you can do it. For this demo, I'm going to go into my portal. I'm going to go find the static web app resource that we had created in previous sections. And with an environment set up already, I'm going to go to Settings and Environments. Here we can see we already have a preview environment. I am now given the option to split traffic. Right now, 100% of our traffic is going to our production environment, which makes sense. But say we want more customers to try out our new feature that's currently in a preview environment. We're going to go ahead and add that. And in this particular case, I only want 30% of my customers going to the preview environment. I'm going to select Environment and set it to Test Feature. I'm going to go ahead and save. And just like that, we now have 70% of our traffic going to our original production environment and 30% trying out our new feature. Now that we've set up traffic splitting, let's move on to something more advanced, Enterprise-Grade Edge. This feature utilizes a content delivery network service to deliver superior performance and high availability. CDN is a scalable and secure entry point for fast delivery of your global application. It offers several benefits, including global load balancing, caching assets, at the edge to help improve your application's performance and improved security. Let's go ahead and set up enterprise-grade edge for your Azure Static Web App in the portal. I'm going to go down to Settings and Enterprise-grade edge, and I'm going to select Enable Enterprise-grade edge. I'm going to select Save, click OK. I have now set up enterprise-grade edge, allowing for my website to perform at a higher rate, thanks to a content delivery network. And just like that, we have now enabled enterprise-grade edge. These are just two of our traffic management features that could be utilized for your Azure Static Web App. In the next chapter, we're going to go over some additional features that can be used with your deployment. Hello and welcome to Chapter 8 of our beginner series of deploying a web app to the cloud with Azure Static Web Apps. Today, we'll dive into a couple additional features of Azure Static Web Apps. Let's get started. The two features that I want to highlight today are snippets and database connections. So currently, snippets inject custom code into the head or body at runtime of your deployment of Azure Static Web Apps. Similarly, database connections connect to a database without using a backend. In modern web dev, connecting your application to a database is often essential for dynamic content and data-driven features. Setting up a backend API, as noted in previous section of this series, can be one solution. But for simple data transactions, database connections provides an easier solution. Database connections allows you to connect your web application directly to a database such as Azure Cosmos DB, SQL, and more without the need for a custom backend API. This simplifies your architecture significantly and speeds up development. Here are a few use cases where database connections shines. Static content enrichment. Fetch data directly from a database to supplement your static web content. Dynamic data display. Display data pulled in real time directly from the database. And prototyping and rapid dev. Quickly build and iterate on applications without overhead of setting up and maintaining backend APIs. Another feature of Azure Static Web Apps is snippets, which allow you to create reusable code blocks that you can insert into your web app with a single click. Snippets are useful for common tasks such as fetching data, displaying UI components, and adding analytics. You can create your own snippets or use the ones provided by Microsoft. That concludes this series. Thanks so much for watching. For more information on Azure Static Web Apps, check out the following link. And as always, happy coding.